Welcome to this OTO spectrometer tutorial. In this video, we will introduce trigger mode, also known as external trigger mode. When a measurement command is sent by a computer, the actual measurement start time may be affected by operating system scheduling, USB transport, and host performance. If the event is very brief, or if several spectrometers must begin exposure at the same instant, software commands alone may introduce timing differences. With external trigger, the spectrometer waits directly for a hardware pulse and starts the configured measurement when the event arrives. This synchronizes acquisition with external equipment, lets multiple spectrometers start from the same signal, and reduces uncertainty caused by delays on the computer side. Use the computer to configure the parameters first and retrieve the spectral data afterward. The external pulse connected to trigger in determines when acquisition actually occurs. Connect signal from the external trigger source to trigger in, connect ground to GND, and make sure both sides share a common ground. Trigger in accepts a 3.3 volt or 5 volt TTL signal. The program must also select the trigger edge. A level value of 1 selects the rising edge. Trigger is detected at the transition from low to high, and the signal then remains high. A level value of 0 selects the falling edge. Trigger is detected at the transition from high to low, and the signal then remains low. First, consider an 8-pin SE2 series model. Read the pin numbers from the front view of the connector on the rear panel. SE2 uses a single-row 8-pin connector. Pin 7 is trigger in, and pin 8 is GND. Connect signal from the external trigger source to pin 7 and ground to pin 8. Do not identify pins only by wire color. Before wiring, check the connector orientation and the pin 1 mark again. Next, consider a 16-pin GB series model. According to the connector front view in the manual, pin 13 is trigger in, and both pin 15 and pin 16 are GND. This video uses pin 13 together with pin 15 as the main wiring example. Pin May 16 also be used as ground if required by the actual cable assembly. Notice that the numbering does not increase from left to right, so use the positions of pin 1, pin 2, pin 15, and pin 16 to confirm the orientation. If the customer wants to use the spectrometer power pin as the external trigger source, use this wiring concept. Route 5 volts through a switch to trigger in. Connect trigger in to GND through a 10 kΩ pull-down resistor and a 1 microfarad capacitor. When the switch is closed, trigger in becomes high. When the switch is released, the resistor pulls the signal back to low. The capacitor helps filter switch bounce. Always use a common ground, and check the product manual for the power pin output capability of the specific model. After an external trigger arrives, the sensor does not start exposure with absolutely zero delay. The fixed time from the selected trigger edge until the device completes its internal processing is called trigger latency. The value can vary with the platform, sensor, readout frequency, and pixel count. The user can also add a programmable trigger delay so that integration time starts at the required moment. The SDK provides set trigger delay and get trigger delay to configure or read the standard trigger delay. Trigger delay real flag set and get configure or query real delay mode. Note carefully, only the real flag API pair requires platform 5 through 6. The actual time from the trigger edge to the start of exposure depends on both the model's inherent latency and the delay setting. If the requested real delay is shorter than the model's minimum latency, the hardware cannot remove that inherent time. Before choosing a delay value, check the trigger latency table for the model and determine the valid delay range. Before reviewing the code, use the SDK flowchart to understand the complete sequence. Without an additional delay, connect first, obtain the frame size and wavelength, configure the trigger count and each integration time, and then enable trigger mode. After enabling, keep checking the status. When the group is complete, retrieve one selected spectrum or retrieve all spectra at once. When delay is required, the overall sequence is the same, except that set trigger delay is called before enabling trigger mode. After retrieving the data, call set trigger IO again to wait for the next trigger group. To finish, set enable to 0 and leave trigger mode. The Python example first imports Python example OTO general. Open device loads the SDK library, enumerates supported VID and PID combinations, and opens the first spectrometer it finds. After obtaining the handle, the program reads the device information. Next, read the frame size and allocate the wavelength array. Frame size determines the number of float values required for each spectrum. The wavelength array provides the wavelength corresponding to each spectral point. Check the return value of every SDK call. Next, configure the number of trigger events to receive and the integration time for each event. The example creates an integration time array and passes it to set trigger group integration time. If every exposure uses the same duration, fill every element with the same value in microseconds. Different exposure times may also be assigned in sequence. If the workflow requires a delay, configure trigger delay before enabling trigger mode. Then call set trigger IO. An enable value of 1 turns the mode on. The timeout unit is milliseconds, and a level value of 1 selects the rising edge. After entering trigger mode, call check trigger done repeatedly. A return value of 0 means ready or group completed. 9 means not ready, so continue waiting. 10 means timeout, and trigger mode must be configured again. Production code should include a short sleep so that the polling loop does not continuously consume the CPU. After the group is complete, get trigger data all retrieves all spectra in one call. First allocate a contiguous float buffer with frame size multiplied by group count. Then reshape the result into a two-dimensional number py array with group count rows and frame size columns. If only one selected spectrum is required, use check done and get trigger data instead. After retrieval, call set trigger IO again if the application should wait for the next trigger group. To finish, set enable to 0. A complete program should use try and finally so that trigger mode is disabled before the spectrometer is closed, even if an exception occurs. To summarize the OTO trigger mode workflow, first, confirm the GPIO pins and common ground. Second, connect and prepare the wavelength array and data buffer. Third, configure the group count, integration time, and optional delay. Fourth, enable trigger and wait for the external pulse. Fifth, confirm completion and retrieve the spectra. Sixth, reset for the next group or exit trigger mode. Correct wiring, the correct trigger edge, and complete status handling are the keys to stable and synchronized external trigger acquisition.